Very good, healthy. I
Healthy?
think healthy, and you
Yeah.
two look healthy as well, so I'm feeling reassured.
Yeah.
I think we're all healthy.
Yeah. Are you glad to be back on campus?
Yeah, it's nice, isn't it?
Yeah.
And I will say, we're very, very lucky here because we've got lovely trees. It's obviously not always as sunny as this in Scotland,
No.
but you know, we've got lovely trees, we've got a lake or a loch. I think we're very lucky to have this so we can come out. So when the weather's nice, you can sit out and you can have a picnic and that kind of thing. I think that's very nice.
What would be a good habit for someone to start in first year?
Oh, good habit. I think the most important thing, and you two maybe will agree with me since you've been through this process, I think the most important thing is just be regular in your work. Don't do too much, don't do too little. So allow yourself to be paced by the lecturers. There's always a temptation, I think, when you first go to university to try and do too much. That sounds odd, but don't do too much. But on the other hand, don't leave it. Don't think, oh, I can do it next week, because work piles up very, very quickly. So what I would say is the best habit is do a little bit every day, keep up to date, and then you'll be fine. Don't go too fast, don't go too slow. Allow yourself to be guided by the lecturers.
Is there a problem that got you into your current field of work?
That's a very, very good question. What happened was, I wrote my PhD, so after you do an undergraduate degree, if you haven't totally been turned off mathematics, you might want to do a PhD, which is what I did. And I wrote my thesis on an area of algebra called semigroup theory. And I remember having written my thesis, sitting down and then having to decide, what do I do my research on? Even semigroup theory is a big area. And I thought about it for a long time, and it wasn't a specific problem. I just came to the conclusion that I would study a particular class of semigroups, and that turned out to be extremely fruitful. I made a very good decision, but at the time it was very difficult. Many mathematicians, if you ask that question, will say yes, it was a specific problem, and they got it. Whereas with me, it was more a subject area that I got interested in. Each has a risk. If you choose a specific problem, you may not solve it, or somebody may solve it before you. If you choose a problem area, there's no guarantee that in 20, 30 years' time that's going to be interesting to people. But as it happens, I chose very well, and the area that I got interested in is one that people are interested in today. So it was an element of luck combined with, yeah, I knew a little bit about the subject, and I brought that knowledge to bear and made a very conscious decision to work in that area.
Have you used your degree outside of maths in any way?
That's a very good question. I think when you do a degree, you have to do it because you find the subject interesting. Otherwise, you're not going to get up in the morning. It's as simple as that. You've got to find it interesting. And then outside of, I think what you learn through doing something like mathematics is maybe a logical approach to problem solving. So problem solving in general. But having said that, I don't think I'm any more able to solve real life problems than anybody else. I'm just as likely to cuss as anybody else if, you know, I'm nailing something and I miss. So I think that's less likely. In my own research, it turned out that some of my research was connected with theoretical physics, what are called quasi-crystals, and that did turn out to be very useful. That was unexpected. I wasn't expecting that. And the fact that I was, I think, well educated in mathematics meant that I didn't turn off that particular avenue of research. But I think in general terms, no, you do a degree because you enjoy it and it means something to you, and if you do a maths degree, it's certainly true that you're very employable in the end. And you will learn techniques for solving problems, but I think the most important thing is to do it because you enjoy it. That's the most important.
Is there something you don't like about math?
No.
Any like specific area of math you don't like?
No, I'm not very good at. That's different. I'm not very good at probability theory. I wish I were. I'm not very good at that, and I shouldn't admit this to camera, but I find it very difficult. And in fact, I talked to a colleague of mine who is very good at probability theory, and he reassured me that in fact it's a known thing. So he happened to have the kind of brain, and occasionally I see it in students. If you're good at doing, I shouldn't say this because you get the wrong idea, but if you're good at things like betting on a horse racing and things like that, I found that people like that are very good at estimating probabilities and have an intuitive grasp. And that's probably why they're attracted to that subject in the first place. But I have no intuitive grasp of the subject whatsoever. I'm purely algebraic, and I wish I weren't. I don't say it to boast, but that's what I am. I'm an algebraist, first and foremost.
It's okay, you're in a safe space here.
I'm in a safe space, that's right, yes.
I kind of regret not taking probability in second year, but then if I had not take, if I'd taken it, then I wouldn't have taken logic and proof, and I loved logic and proof.
I think I think the one thing that is a shame about university is you do have to make choices.
Yeah.
A lot of people come and they think they can do anything, and unfortunately, you are constrained mainly by just the timetabling, but also by prerequisites. But I think the past year has taught us just how important probability and statistics is. And I've observed as a sort of outsider just how badly probability and statistics has been served by the media. And I hope that people will come with an appetite for at least statistics. And in the first semester, you're going to do a course called Stat Science A, and that's supposed to sensitise you to the importance of statistics. And I think already that's probably a job that's already been done. Because, you know, how can you make sense of all this information about COVID-19 unless you've been sensitised to it? But it's important beyond that. Probability theory crops up in all kinds of areas of mathematics now. And it's also very important in things like renewable resources. So, for example, wind power, you see a lot of wind turbines, but they don't move all the time. So you have to model this to see whether it's really worthwhile putting a wind farm in a particular place. So probability has really down-to-earth, real-life applications. It's very, very important. But I can't.
What is your favourite part of your course?
Actually, to be honest, I like all of it. I really like what I'm doing at the moment, which we're looking at a generalisation of Boolean algebras, and I talked a little bit about Boolean algebras in my logic and proof course. And we've generalised it to what are called non-commutative Boolean algebras, and you can look at them from so many different points of view. It's inexhaustible. So everything I do I find interesting, otherwise I wouldn't do it. I'm very lucky in that I do what I find interesting. If I were being paid to do the job, you know, by a company, then I'd have to do what they wanted to do, and I'd try and do it as best I could, and a lot of people have to do that. The great virtue of research in a university is, in theory at least, is blue sky thinking. You can think what you want and follow where you want to go, and that is wonderful. So everything I do I enjoy doing. The hardest part is proving theorems, but every mathematician finds proving theorems hard, and you just have to accept the fact that it may take you weeks to figure out how to do something. It's just the name of the game.
Last question. What should you take away after 4 years of studying?
Two things. First of all, I hope you'll make some great friends, which is what I did. So you'll take away some friends, and in fact I'll be seeing them in a few weeks' time. Some friends that I made during my first couple of weeks at university. I'm still friends. So you'll make a lot of good friends here, and that's very important. The other thing I think, particularly from a maths degree, is you will take away an attitude of mind to solving problems. And that will help you a lot when you're applying for jobs, because you'll be applying for jobs where they will want you to think for yourself. It's not necessarily that you'll have an answer, but that you won't run. If they give you a problem, you won't run from the room screaming, saying, I can't solve it. You'll sit there and you'll think your way through it, and you'll look at the various options that you have to try and solve the problem. And that, I think, is one of the most important things you learn studying mathematics at university. But as I say, two things. One is you'll make some great friends, and that's very, very important for the rest of your life. And the second thing is, specifically studying a maths degree, is this ability to approach problem solving in a rational way.
Is there anything else you want to mention?
Yeah, there was one question you didn't ask me, which was how I got interested in mathematics.
Oh yeah, that's a good question.
And I think I'm going to tell you that because...
Yeah, I want to know.
Yeah, well, I was very lucky because I grew up in the 60s, and the Americans were spending billions of dollars and the Soviets were spending billions of rubles in sending rockets up, just so I would get interested in space rockets. So it was very kind of them. And it was through that interest in rocketry that I became interested in physics. And then through physics into mathematics. And then I stopped at maths because it seemed to me that maths underpinned everything. If you could do maths, you could do anything. Whereas if you could do physics, you could be a very good physicist. But you wouldn't necessarily be a good mathematician, whereas if you were a mathematician, this was my idea anyway. So it was actually through the space race how I got interested in mathematics. And I suspect a lot of people of my generation became interested in the sciences, whether it's mathematics or physics or whatever, through watching these rockets going up every week and hearing people talk about the science and engineering of these rockets, and you couldn't help but get interested. So I was very lucky that these two great countries were willing to spend all that money so an 8-year-old me could get interested in mathematics. I think it was money well spent. So when people ask you what the space race gave to you, there were two things: the Teflon frying pan and me doing mathematics. That was quite painless.